Okay, as promised, we are doing a video about lift and also specifically about the airfoil and why this is important. All right, there's a lot of information that I could say here. I might break it up into a couple videos, but this is kind of an intro to aerodynamics and how air molecules work and why planes fly. To me, it's really interesting. To you, it might be really boring. So, this is actually how I originally taught Zeru about how an airplane flies. And I want you to imagine all of these air molecules over here. And this is just the air. Here's the side of the airplane wing. Okay, so the airplane here is flying through the air. All of these air molecules are just doing their own thing. But then what happens all of a sudden is you have this airfoil, which is, like I said, the side of the wing. Okay, so just imagine this is the airplane, and it's flying through the air. Okay, so it's flying through the air this direction, so you can imagine like wind coming over the wing. So let's think about what's happening here. Okay, so again, this is the airfoil. That's what we call the shape of the wing if you were to take the side of the wing, cut it in half, or if you were to stand on the side of an airplane here and you were to really look at the shape here, it would look something similar to this. Okay, so this side of the airfoil we call the leading edge. This is the edge of the wing that leads. It's the one that goes into the wind. It's punching into the wind here. This is called the trailing end. It's the end that's trailing. It's at the end. So this is the direction that the plane is going, right? It's going this way and the air is going to go over this. This is a very important line. There's a lot of different lines, but this is called the chord line, and it goes from the front of the leading edge to the back of the tailing edge here, and it just cuts straight back. It doesn't do any curve or anything. It's just a straight line. Now, a little further on, you'll learn a little bit more about this chord line, why it's important, angle of attack. You start adding flaps, things happen. But just for basics, this is called a chord line when you go from the leading edge of your wing to your trailing edge of your wing or of your airfoil. All right, so we are going this direction through these air molecules. What is going to happen and why? Well, as the air molecules hit this shape, let's think about what might happen. Okay, and we've learned a little bit about drag. So obviously this front part here is going to naturally produce a little bit of drag because it's going to be running into the air molecules. So what's going to happen then? So then they're going to go around the wing. They have to. What I like to think about a lot of times is if there's a river and it's running this way and you decide to put a big rock in it, okay? I'm going to stick a big rock. That's a funny shaped rock. We'll just put this rock in here, right? What's going to happen to the water? Well, it's going to go around it, right? Well, what's going to happen when it goes around it? It's going to hit the front of the rock, the face of the rock. It's going to move around it, but then what happens in this front section here? It's going to kind of make a little dip in there. Like it's not going to have quite as much water. The water isn't necessarily going to swash back around and go that way, or it might make a little eddy. But the point is that when the water goes around it, it's going to smack into the front, go around the sides. Depending on the shape of this rock, the water is going to behave differently. If you've ever seen a moving river with rocks in it, you know. So it's no different with the air. The air is a fluid with molecules, so imagine it just like water. So you can actually imagine if you were to put an airplane wing in the water, what would happen to it? So here we have our air molecules. You can imagine it's like water going around. And what's going to happen? Well, this flat side, you notice the bottom of the wing here is flat. It also oftentimes has a little bit of a concave here. So what's going to happen is you're going to end up with these air molecules catching. They're not going to go super fast. They're just going to kind of hit and just kind of congregate down here, right? But if you look at the shape up here, they're going to smack into it, and these little guys are actually going to kind of bounce upward if you think about it. Okay? So just imagine it. Here's coming at it. The air is going to hit, and it's going to kind of do this. Okay, you're going to end up with less air molecules floating close to the top of the wing than you would at the bottom of the wing. The bottom of the wing is going to have a lot more of them because they're going to partially catch here, and also this is flat. They're just going to kind of hang out there. This is going to force them away. Why is this important? Each one of these molecules you can imagine as being a tiny little grain of sand or a tiny little drop of water. It each has its own little and middle, tiny amount of force. So it's not that heavy, but just like a paper plate isn't very heavy. But if you took a stack of paper plates from the ground all the way up to space and you tried to lift that stack of paper plates, it would probably be very heavy. Same thing with air. Air actually has weight to it. It has mass to it. It's got something to it. It's not just invisible nothingness. So all these little air molecules are a fluid. They're going around this airfoil. The top ones are spreading out. The bottom ones are close here. So what happens here? These are each exerting a certain amount of force in all these different directions. It doesn't matter, but they're all exerting some force. They exist. There's mass here. These are also exerting their force in all these different directions here. There's some mass there. So what do you notice about the top and the bottom? There are a lot more at the bottom than there are at the top. So what does that mean? That means that there's more molecules pressing up than there are molecules pressing down. You could also think of it as there are more, if it was water, there's more water underneath it, and there's almost no water on top of it. Or there's more sand beneath it, or there's less sand on top of it. If each one of these were a living person and they were itty bitty, and they were all trying to push on the airplane, obviously if it was like a game of tug of war but pushing, these bottom molecules would win. In basic science, you have air pressure, which is literally the air is pressing. There's going to be a lot more air pressure down here because there are more air molecules. There will be a lot less air pressure up here because there are less air molecules. So if you think of it that way, it makes it a little easier just to visualize it. So this is going to end up having like a vacuum, a low pressure system and a high pressure system. So you're going to have a lot of pressure and almost no pressure, which means the airplane is going to go up. There's a vacuum sucking the airfoil up, simply because you have the shape here. The air molecules are coming. These ones are going to go around. If you ever get the chance to look at a wind tunnel with the experiment of the actual airfoil in the wind tunnel, you'll see the smoke coming at the airfoil, and it'll actually do something similar to this. And as you move the airfoil, it changes the patterns of the wind, which is really interesting. It explains a lot about when you're flying what's happening. So your wind in a wind tunnel would look something similar like this. It would lift away, separate away a little bit from the top and give you some space, give you some breathing room up here, but it would still catch down here. So it's going to cause a low pressure system and a high pressure system, and it's going to push the airfoil up. Okay, so there's a little more detail. This isn't like the exact right answer when you go to do your knowledge test, or if you're doing your oral for your practical, or even if your CFI is talking to you. However, I want you to envision this because it's technically true. You have a low pressure system up here, you have a high pressure system up here, or down here, and you start off with just regular atmosphere. And as you're plowing through it, the air molecules are separating and doing different things, which causes the airfoil to do its thing. So next, in a different video, we'll be talking about Bernoulli's principle. Now that is the real reason they say that an airplane can fly, is due to Bernoulli's principle. Bernoulli's principle also talks about high and low pressure, which is why the wing will lift up. But the reason Bernoulli says there's a low pressure system on top is a little weird, so we'll discuss that in a different video. And I honestly don't agree with Bernoulli. Him and I have a love-hate relationship. So as far as this is concerned, this will help us talk about not only lift, but it'll also help us talk about flight controls in a different video. So that'll be an important one. But really quickly, I want to describe what is going on here besides lift. So the airplane's lifting, yes. We previously said in a different video that drag, there's a type of drag called induced drag that is always created when you create lift. Now, what do you think happens? We have these low pressure systems, this high pressure system. What do you think is going to happen when this air gets to this area here? Well, what do we know about high and low pressure? High pressure is going to want to go to the low pressure. It's like having a big empty tunnel and having a bunch of water, and you pop a hole in it, it's going to want to go to where there's room to go. So you have all these molecules, you have this open area here. What are they going to do? These are going to try to go up here. Well, why? Well, there's a high pressure system and a low pressure system. They're trying to press up. And there's space here. There's that low pressure. So literally these are going to press up. And then what? They're going to come in here and they're going to come down here. And then they're going to hit this tip of your wing right here, this trailing edge. So there's actually going to be this drag right here being produced. Why? Because you're producing lift. As soon as this airfoil breaks this apart, these air molecules create the high pressure system and the low pressure system. And these are trying to bump up, bump up, bump up, and as soon as they get the chance, they break free and suck their way into this low pressure system. So they're literally doing that. So if you imagine the plane, and I'm sure they make that sound, if you're seeing a plane here, okay, you have your high pressure system, your low pressure system. And these are coming over here, and it's going to come up. It's also going to come out this way and come up this way. So imagine it's going to come up and around like this, okay? Out from the bottom, up and around towards the wing, okay? Why do I keep saying that again and again? This is actually a question in your test. It will ask you about wing vortices, the wingtip vortices. What direction do they go? Well, at first I didn't think it was that important, but when you think about that it's creating drag, it actually is kind of important. So it's coming out and around and it's hitting this, okay? There's other things you should think about. Besides drag, this is going to come out. It's going to do this, right? You're in the air. So what's happening here? You have this swirly junk in the air, okay? It's pressing. It's a force to be reckoned with. If this is a really big jet and you're flying somewhere behind it, whether it's, you know, on a final approach or you're taking off behind it, you have this big force here. So if you're a little plane and you're flying through this, you might actually interact with this and end up having some serious issues. So being aware of how this works is important for that reason. Now, on a personal reason, if you're not behind any aircraft, the other thing is this is fine and dandy in the air, but let's say you're coming into land. Now you have, let's get a different color for our runway here. You're coming into land and here's your runway. Okay, so what do you have here? You now have this wind force pushing down. It can't push past the runway, so it's going to stop right here, right? So you have this force pressing down on the ground. Okay, so you have these wingtip vortices and they're hitting the runway and they're actually causing you to not land as easily. Now, this is sort of important because what happens is when you're learning how to land, you'll notice you go to land and then your plane doesn't quite want to get on the ground and you can't figure out why. You're like, oh, I was going fine, and then all of a sudden I'm floating here above the ground. Why? Well, this is why. There's actually a special term for it, but we can get to that in a different video. I just wanted to explain that when you're creating lift, you're also creating this drag and these wingtip vortices, and you can see why this is happening with your high and low pressure systems here. So I hope you kind of understand that. I hope you have a good visual of why the airfoil works the way it does. And I want you to remember this is called the chord line, which will be important. It is from the leading edge to the trailing edge of the airfoil.